Hello and welcome to Web Learning, where knowledge is shared. In this episode, I'll continue and show how to communicate with the BlueNRG-1. If you haven't seen any of the previous episodes, please go ahead and have a look at them so you could follow up much better with this tutorial. In order to get the BlueNRG working with the BlueNRG GUI that we'll need to use, we'll need to demonstrate application, BLE, DTM, UART 16 MHz, and flash and run. As I have already done this in the previous tutorials, please go ahead and follow them and come up to this step. In this episode, as I said, I'll show how the source code is working compared to the BlueNRG GUI. In the GUI, in the previous video, I showed how to do a chat with a mobile phone. So in this tutorial, I'll show how the chat is compared between the GUI and the source code. In order to open the source code, again, we can use the navigator, chat, server, and open the project. In the project, this is the main project. I'll step up and I'll open the MDK arm, that is the Kyle. This error message means that I don't have the right Kyle environment for the BlueNRG-1. In order to update the Kyle, what I need to do is click on the pack installer, file, import. Then you can go back to the project, right click on the file, open chat, right click on the chat, and copy full path. This will give us a start to where to look for the files. We'll go up and another one and another one. Then you can see under utility, there is the Kyle BlueNRG update. I'll click open. It's installing. And that's it. So I'm getting a new message. Yes. And let's see that everything is correctly being set. We can see that the BlueNRG-1 is fine. The target and the flash and everything is set correctly. If we'll try to compile this, 0 errors, 1 more warning, so it just says that num pages was never used. It's not important for this example. So now I have them a window next to window and we can follow up the procedure. So the first thing we need to do is init device. Again, we have general. We have the set address, either public or random. We have the device name length, 7 bytes, and the set BlueNRG device name. And this time I called it Blue Web. I'll click OK. We can see that everything passed correctly. So the first command that we have is HSI reset. This is because the board is already powered. We need to reset it. And the second command for the chat window that we're going to do is ACI HAL write config data. So those are the basic settings that the GUI is using. If we go to the software, the first thing that we need to do is make sure that we're running the right chat program. We need to change this settings to server. We'll try to compile it. And everything is fine. 0 errors, 0 warnings. Now after we made sure that everything is correct, we'll open the BLE chat main. And this is our main window. In the main window we can see some includes, some definitions, system init, SDK violation identification to make sure that we're using the BlueNRG-1, clock init, SDK, Valcom config, so all the IO communication channels there are fine. And we have the BlueNRG stack init. The stack init is the actual stack that's running in library, and this is the actual code that's running in the background for the BLE. If the stack loaded correctly with all the settings that are in the init parameters, and we have success, then everything is fine. If not, we'll get an error message, the BlueNRG stuck in initialization. Now because we're running the server, now we have a if it's a server, then printf. If not, it will be the client. Now we're running the server, so we'll see this printf on our terminal. So the next command is chat device init. We'll go to this function, and we have this function, chat device init. So few parameters. Now you see that we have the BlueNRG-1. This is the name. The name that we chosen is BlueNRG Web. So here we can change it to BlueNRG Web. And we'll call it Web1. If it's a server, well, it is a server. So our role will be GAPRFL role, and our address will be this address. Again, this can be changed. Here where everything is getting more interesting, and you will see that it corresponds to the GUI. For example, the HSI HAL write config data, you can see that it's the ASI HAL write config data, so it's the same function. With the config data bus address, this will go, and we can see it's 00, and we can see that the config data bus address off, it's also 00, so we can see it corresponding to this information. If it's success, so the address is fine. If it failed, then we see this setting bus address failed. Next command that we can see is HCI HAL set TX power. And if we go corresponding to the source code, we can see again HSI HAL set power level 1 and 4. So we have 1 and 4. So high power 1, P level 4. If you go to the next command, HSI got init, we can see we have the same command. Again, if we're getting an error, we have the error printed in the terminal. We'll step down. We have ASI gap init. We'll go to our code. We can see that we have ACI gap init with the role and the addresses and the service handler. This was the last command in the init device. Here there's a few more things that are need to be set, and this is what we'll do with the service management. So quickly, again, if you haven't followed this, I recommend you to go back and watch the videos. So after I did the service management, we can see that we have a little bit more of the send and receive packets command. And here we have the add chat service. If we go to the chat service, we can see that here we have the unique ID, the char unique transmit and receive. And they're using 128-bit unique ID. Here we can again see the ACI get add service. In this window, the ACI get read handler, it reads all the handlers that are open in the system. So we can see 01, 02, 03, 04, 5, and it keeps on going. So those are all the handlers. Then we have ACI get add service, and we can see that we have ACI get add service. The service with the unique ID type, 128 service unique ID. We can see also this is the unique ID. Because we didn't use a unique ID, we only see this. And then we have got add char. We can see here ACI got add char. with the jar handler and all the information. The next command will be ACI get read handler. So the next service is just to see that the handler is in the correct address. And we have job finished. Here again we have all the services. If it's success, it returns back. Coming back to the chat, so we had the service, we had the add chat service, that was fine. And we're back to the main. If it wasn't a success, then we know it didn't work. So BLE stack initialize, we know that we did the init device and service management. So we need all the stack as we needed to. Now we need to do advertising. So I'll clear list. I'll click advertising. Again, the select mode, the intervals, the local name. We'll click OK. So after advertising, we have the HSI LE set scan response. Now if we go back to our source code, we can see that we have while one, BlueNRG stack tick, and application tick. Now for some reason, as I showed you, we're supposed to see this command, but we cannot see it. So how does this software initialize? So really quickly what we can do is click on the command, click Control copy because there is no right click, and we can go back to the code and we can search for this command. Now we can see it's located few places. If we go and start searching for it, we can see that we found it in some code, and we can see that the actual function is make connection. If we look for this command, again we can see it's being called a few times. Here it is, make connection, and here it is again. So it's being called from here. And if we look really carefully, we have app tick. And if we go back to the main, we can see that the app tick is calling the make connection every time it works. So this is the stack tick in the software as I showed in the beginning. So make connection is under the app tick, and we can see that the app tick is part of the while one. So every time the BlueNRG gets a stack tick, so it wakes up, it initializes, and you get the app tick. The app tick gets advertising, and the source code keeps on running. So let's give it a try. In the previous window I showed how the GUI works, so in this case it's time to show how the source code works. So we compile it, we have 0 errors, 0 warnings, we're still on the server. We can see that there is a bin file that was created in this location. So at the end we got the BLE chat server.bin. The quickest way to program the board is we'll open the Flasher utility that's also in the installation. We'll click select file. As before, we'll take the copy full path of the project, replace it in the address. We'll go back. This is the project, and we did the server, and under the server we have objects, and here is the bin file. We'll click open. This is the COM port we're using. We'll click flash, and everything is fine. Click OK. We'll click reset on the board. We'll go to the mobile phone, and we can see here that the code is running. We have BlueNRG chat. It's being connected. We'll click connect. We can see the custom services. At the same time, we'll open the terminal window. In order to do that, we'll first have to close the flasher because the flasher holds the COM port. Okay, so I opened the Docklight, one of terminal software that you can use. I set it to 3 at 115/200. I'll click OK. I'll click reset on the board. You can see that all the software ran okay, so we're in the chat server application. Got init success, gap init success, got update char value success, chat service added, transmit char handler, and Rx char handler, add chat server success, BLE stack initialized, ACI gap set discover. So everything worked okay. We'll clear this window so we can follow it slowly. We'll click connect. Everything is fine. Now if I want to write something, I'll click, for example, AA, click OK, and we can see AA. That's it. I hope you enjoyed the presentation. If you like this video, click subscribe so you'll get more notifications when I upload new videos. Thank you.